If you keep cutting a piece of paper in half and in half again, eventually you'll get to a point where you can't cut it anymore. But are we sure that's really the smallest unit? The answer starts with the atom. J.J. Thomson was experimenting with a new technology called the cathode ray tube. The device was made up of a glass tube and two metal chips connected to a battery. When Thomson turned the battery on, a ray would shoot from the metal chips. Curious to know more about this ray, Thomson added electrical charges and found that the ray would always bend towards a positive charge. This strange behavior alerted Thomson that the ray must carry negative particles. The first subatomic particles discovered, electrons. In order to explain his discovery, Thomson pictured the atom as plum pudding, negatively charged plum electrons scattered through positive matter. But still, some people weren't convinced. So in order to settle it, his students set out an experiment that would go down in history. Using radium, Rutherford fired a ray of radiation towards a sheet of gold foil. In line with Thomson's model, he expected the radiation to mostly pass through. The results were startling. Rutherford was finding that on rare occasions the radiation would bounce back, as if hitting densely packed cores somewhere in the atoms. Those cores were the nucleus. In the early 1900s, the results from spectral lines were raising questions. These graphs showed that atoms gave off light in sharp, distinct colors, not smooth rainbows. To accommodate this discovery, Bohr supposed that the electrons orbited the nucleus in fixed energy levels. This model explained the sharp, distinct spectral lines, as electrons of a certain energy level would all contain the same energy. But Bohr was troubled by his success. According to classical physics, the electrons in his model would eventually spiral towards the nucleus and destroy themselves. So either Bohr was wrong, or he had just broken classical physics. Feynman once said that if all of science was to be reduced to one statement, it would be the atomic hypothesis. It was the single most fertile task in all of science. But more than what we learned about the world, we also learned about ourselves. We are curious people who dare to find the invisible particles of the world, yet also cut even deeper.